So we will be seeing in today's session from vector calculus, we will be covering topics differentiation, partial differentiation, especially our Jacobian, okay, or gradient. I would say gradients and Jacobian are very important concepts. They are widely used in machine learning. So these things maybe we'll just quickly revise what is differentiation, what is partial differentiation, but the focus will be on gradients and the Jacobian. What is a Jacobian? What is gradient? Why we need this? Because when we study regression analysis, it is very important for us to know the how do you optimize a regression model using gradient descent technique. Okay, though there are multiple advanced concepts exist in this optimization, we are going to see the standard technique of optimization using gradient descent. So we will first see what is a regression. So this is a diagram which helps us why we need to study vector calculus. So when you study the difference quotient which defines the partial derivative, differentiation, partial differentiation. So we talk about partial derivative. So partial derivative are used in regression, they are used in dimensionality reduction and also in classification. Okay, so these three mostly define our ML concepts. Anyhow, it's used in optimization. So we try to, this is the very important application of derivatives, because we in lot of computer science problem are represented as functions, and those functions depend on some parameters. Okay, and we have to optimize those parameters to form the best models. So this is one very important concept, optimization. In general, if you are a computer science student or you want to do you do higher education, you need lot of this, or you're working in research, you need to know about different optimization techniques. So one such optimization technique which uses partial derivative, which we are going to see, is optimization using gradient descent. Okay, so this is just an example, a pictorial representation. It shows where and how these partial derivatives are useful. So we will begin with learning regression, and then we'll come back to this differentiation. Again, we'll go back to regression analysis. Okay, so let's see about regression. Regression is a mathematical concept. Okay, not a machine learning concept, it's a mathematical concept. In terms of machine learning, if you say, this is one of the powerful algorithm what we have in machine learning. This is mostly used for prediction. This is used in prediction. So we have seen a lot of examples in previous, I think in one of my lectures we have discussed understanding ML terms in simple, right? Understanding ML algorithms in simple terms. There we have studied that linear regression is used for prediction. So for problems like where you want, for example, you want to save your money for purchasing a bike from today. So you want to save your money. So this regression will help you in identifying how many months do you have to save so that you can purchase the bike. Okay, or you want to go for a tour or a trip, you how many months do you have to save your money so that you can go for the trip. So for those kind of predictions we use linear regression. In mathematical terms, if I talk here, uh, you have x and y axis. So if you talk mathematically, there are lot, we have, see, how am I doing that, how am I able to tell you that the number of months required for bike purchase? It is based on the historical data, it's based on the ML data. You have ML data, using this data you try to build a regression model. You try to build a regression model. This regression model will help you in doing the prediction task. Okay, so when you have the ML data, okay, if I plot it as no data points in an XY axis, something of this kind, right? So regression is about trying to find out a best fit line, trying to find out a best fit line. Okay, so in maybe in your early education, you might have studied about line equation is mx plus c. So you have done already regression. It's nothing new for you. You have solved lot of problems in finding out the value of m c given values of y and x, right? So maybe sometimes it's called as slope intercept form. Slope intercept form, right? Y equal to mx plus c. Same thing, but instead of writing these parameters, we write here y equal to wx plus b in our machine learning. Okay, so finding out the best fit line is our goal here in regression analysis. Given a data, you have some data with you, which is maybe the values of x and y are given to you. Okay, so using these two x and y value, you have to form an equation wx plus b, or else in your term, I will say mx plus c, whatever you think. So you have to form an equation wx plus b. Once you form this equation, this is called your regression model. Regression model. So this regression model will help you in doing predictions. Why I need this regression model? So this is the, maybe this is the data of a company. Let's assume you have an e-commerce company. Okay, kind of Flipkart or Amazon. So they spend a lot of money on ads. They spend a lot of money on ads. So we have a variable x and y. So if this is the ads amount, right? So this x represents ads money, how much money I have spent on the ads and how much profit I am making, or how much sales I am making. Okay, so company, this e-commerce company ABC is investing, suppose if they invest 1 lakh. Okay, so assume they are getting some profit of 6 lakhs, some simple data. Okay, or let's take a sale in numbers. So 100 products are sold. So when they do this 1.1 lakh, 120, 1.3 lakh, it is 130 sales. Okay, sometimes 1.4 lakh, so it is 90 only. So like this data is given with you. You have an historical data. Last 1 year, 12 months, they have this much of investment they have done, lakhs of rupees in advertisement, and how much sales they have got. Okay, so regression has multiple meanings here, multiple understandings. One is used for prediction. Second one, finding out the relation between these two variables. Regression also talks about relation between two different variables, x and y. Checking whether when I increase the advertisement cost, my spendings on the advertisement, is the profit or the sale increasing or not. Okay, so between two different variables, we are trying to find out a relationship. We are trying to make a insight. When I'm increasing the money, the money spending for advertisement, is my sales increasing or not? This can be found out. Or using this data, if I want, there is one question. This is my historical data. The question here is that you want to get 1,000 sales in a month. You want to get 1,000 sales in a month. So how much money you should spend on advertisement to get 1,000 sales? You want to do some prediction. You want to find out the value. For that also you can use this regression model. So linear regression, whatever you have with you, that can be used for doing this, finding out such kind of questions, right? So if you want 1,000 sales, or maybe if I invest 2 lakh rupees in the advertisement, if I invest 2 lakh rupees in advertisement, how much sale or profit will I be making? Okay, so lot of things exist. Here I talked about one thing called variables, relation between variables, relation between variables. Okay, relation between variables. So this I said that regression can be used to find out relation between variables. What are those variables? X and y. In our case, in our example, our x is the advertisement, cost of advertisement, and here it is sales, number of sales, maybe number of sales, right? So sale is dependent on which one? Sale is dependent on the advertisement cost, how much money you are spending on the advertisement. So sales is dependent on this. It means x is an independent variable. X is independent variable and y is the dependent variable. Y is the dependent variable. Okay, so X is independent because that is what I am increasing. Just a second, I am getting some emergency. Right. So X is an independent variable. Sorry, X is an independent variable and Y is a dependent variable. Okay. So we write when we write mx plus c, it is clear that Y is dependent on X. Y is dependent on X. Right. So this is about regression analysis. Regression. Here there are multiple kinds of regression. First one is simple linear regression. We'll see a numerical example how we try to generate a regression equation. Simple linear regression. In simple linear regression, if this dependent variable y is dependent only on a single variable like this wx plus b, this y is dependent on a single variable. When it is dependent on a single variable x, I think you remember when we studied about principal component analysis, we have seen little about regression. I think we already studied this all information that when you have the I think wind speed, right? The wind speed is given to you. How much power will be generated? We have seen one example. A windmills are there. So, what is the speed of the wind? So that given the speed of the wind, how much power will be generated? In that case, the power generation is dependent only on a single variable. Power generation is dependent on a single variable, wind speed. But sometimes power generation depends on wind speed plus the current temperature also to get the how much power is getting generated. Okay, so wind speed plus the temperature also plays a game. So this way, the point here is that when it is dependent on a single variable, when y is dependent on a single variable x, when y is dependent on a single variable x, we say it as simple linear regression. Okay, suppose y is dependent on multiple variables like x1 and x2, then we call as multiple linear regression. So in this case, the equation will look something like this. Maybe y equal to w1 x1 plus w2 x2 plus b. In this case, y is dependent on two variables x1 and x2. Like the amount of power generated depends on the wind speed as well as the temperature. Sometimes wind speed, temperature, pressure and humidity, all four. In such case, your equation look like W1 x1 plus W2 x2 and so on plus B. Okay, so all this is called multiple linear regression. Right? So regression is one very powerful technique used for prediction. It is used for finding out the relation between two different variables. Like an example I said, if the investment on sales increases, check whether the profit investment on advertisements, if the investment on advertisement increases, is my profit increasing or not? To make, that's what we are doing here. So when you have the values of x and y like this, what we do, we try to form an equation, a best fit equation, a straight line we try to draw. Now this equation is your regression model. Using this regression model, you can find out, you can do the prediction. Okay, so you have done some investment on the ads. You are asking a question. You have got a equation now. You have got a line equation like this: y equal to mx plus c. Once you got an equation like this, you can ask queries to this. If I want to get 1,000 sales a month, how much money should I invest? So your y value is known to you. What is the value of x? You have to find out. For that, first we have to find out the values of m and c. First, we have to find out the values of m and c. How we can find out these values? I think during solving system of linear equations, we have studied this. We have seen how ML data is converted to system of linear equations, which is converted to your matrix, which we are again trying to solve this matrix using a different Gaussian elimination method and find out the values of W's, find out the values of unknowns. Okay, using these unknowns, you get an equation y equal to mx plus c. Some example, y equal to 10x minus 3.5. A simple example can be like this, right? So this is your regression equation. But what is the actual procedure? There are multiple ways of finding out this regression equation. Let's see a important one way of mathematics. Again, I think you by this time you are aware that all these things can be calculated in a single click of a Python code. You write a single line of code, you give the values of x and y. It will tell you in a single click. It will tell you the linear equation. Okay, it will give you the regression equation. Regression model will be generated within some milliseconds. But though this course is mainly aimed at understanding what is the underlying mathematics behind those ML algorithms, how and why they are created using mathematics. So we'll take a small example now. We'll try to see one mathematical approach of finding out a regression equation. Given some data, given data to you, you will try to find out a regression equation. We'll try to find out a regression equation. We do this in Python, but we are going to learn it mathematically. So let us take the same example of advertisements and e-commerce. Let's try to solve it together and try to find it out. So I will just tell you the data, then I will tell you what is the. So maybe we can see that as well. The procedure for finding out the regression equation is simple. See, you have to find out y equal to mx plus c, or in always I will be using my language, y equal to wx plus b. So you want to find out the value of, or some cases they say y equal to beta naught x1 plus beta 1. Okay, so this is from mathematics, this is from machine learning, this is also in mathematics. Different styles you can follow. Y equal to beta naught plus x1 plus beta 1. Okay, different ways, but ultimately it's same. So given the values of x and y, given the values of x and y, how we try to find out. See the so assume the equation is y equal to beta 1 x1 plus beta naught. Assume this is our linear equation, beta 1 x1 plus beta naught. I want to find out the value of beta 1. Beta 1 can be found out like this: sigma I equal to 1 to n yi minus y bar into xi minus x bar divided by sigma I equal to 1 to n xi minus x bar whole square. Okay, so this is one mathematical equation which will help us in finding the value of beta 1. We want to find out beta 1. It's an unknown for us. There are different ways of finding beta 1 and beta naught values. One is using by converting those equations into that data into matrix form, solving that matrix and finding out the value. Okay, but that in that case, if you have multiple features, it is useful. But if you have only one feature, like simple regression, simple linear regression, I am talking about. So when you have only one dependent and one independent variable, this is the approach. So given the values of x and y's, you can find out beta 1 using this, and you can find out beta naught by doing this y bar minus beta 1 x bar. Okay, y bar minus beta 1 into x bar. So this way you get the values of beta 1 and beta naught. So what's the equation? Simply, suppose if you calculate this, it is some 17 and this is around 3. So your equation will be 17x plus 3. This is your regression equation. This is your regression equation, right? So we will take a small example, try to understand maybe a simpler one, which will help us in calculating the values. Okay, I will take a small example where we are given the values of y's and x and how you construct the regression model using these formulas. So it's very simple. Beta 1 yi minus y bar into xi minus x bar divided by xi minus x bar whole square summation. Okay. So this is the given data to us. Car age. So question here is that identify the relation between the age and price of old cars. So x is given to us, that is car age, and y is given to us, that is the price. So car age 4, 4, 5, 5, 7, 7, 8, 9, 10, 11, 12. So you have this x and also you have y 63. This is in some dollars maybe or some numerical value. 57, 45, 45, 42, 41, 31, 21, 25, 22. It means you see this is the age of the car and this is the price of the car. So second hand car, if it is 64 years old car, its price is around maybe 63,000 or not 63,000, 6,30,000. You may assume in that way. Okay, it's a numerical value given in some dollars or some euros, right? So if one car has been, this is the historical data. This data is given to us, which is historical. It means it has been collected. Real time data has been collected. So that's why you see when there are two cars of 4 years age, the price is difference. There's difference in the price. Okay, historical data. Past 1 year, this is done. Now you want to find out the relationship between these two. Okay, somebody gives a new age of the car, you can tell the price. You can predict the what could be the price of that particular second hand car. So this way. Now what is our goal here? You have to find out x bar and y bar. So quickly, if you find out x bar and y bar, I think you are using some calculator. Please use it and tell what is the value of x bar and y bar. Means of those two variables, x bar and y bar. So if I do it, so we are having 11 data. I think this is 82 by 11 if I do. So it's around 7.45. 7.45 is your x bar. Similarly, you try to find out, calculate the value of y bar. Please use some calculator and tell me what is the value of this y bar. Mean of this price. You can observe that the data, when the age is increasing, automatically the price is decreasing. But still, we want to find out the equation and check when we try to give some value between 7 or maybe some value here. 6 is missing. We can try for 6 and check whether the price falls between this range or not. If you calculate what is the value of y bar, so it's around 39. Okay, so x bar and y bar values we have found. Now you try to find out the value of beta 1. So we have seen the equation of beta 1. Here if I write beta 1, nothing but sigma I equal 1 to n yi minus y bar into xi minus x bar by summation of I equal 1 to n xi minus x bar whole square. So let's calculate this for each of these values. So first one, yi minus y bar, so that 39, 63 minus 39. So if you do this and if you find out the value of beta 1, if you apply this data into this equation, I'm directly writing it. You please try to calculate it. You get the value of beta 1 as minus 502.4. This is your beta 1 value. Similarly, if you find out beta naught, we know that its equation is simple. There's a beta naught is given by y bar minus beta 1 into x bar. So this way, if you find out it is 39 minus 502.4 into 7.45. So this minus of minus becomes plus. So if I calculate it, somewhere around 3742.88. Okay, plus 39 we have to add. So 3745, right? So this value is around 3754. Sorry, 39 plus 3781. Okay, 3781.88. So you got beta naught, you got beta 1 values. What is your equation here? Line equation, y equal to beta 1 x1 plus beta naught. So this forms your regression equation. So in this, if you write here y equal to, I'll write minus 502 minus 502.4x plus beta 1 is 3781.88. So this forms your line equation, which gives the relation between the age of the car and the price. Okay. Now with this model, you can find out, you can give any age of the car as the input. It will tell you the price for which we can purchase that used car. Okay, so this is the procedure how we find out the regression equation. We have also seen a different technique. There is matrix approach to find out this. Like this, we have different techniques. This is one way you can try to solve the regression. You can try to find out the regression, which helps us to find out the relation between two variables. One variable is dependent and independent variable. Okay, now again there is one point here. So let's discuss that. See, you formed this model, you got this regression model using this data, which is an historical data. Using this data, you try to form an equation like this. You got this y equal to beta 1 x1 plus beta naught x naught. How we framed this regression equation using this data. Suppose if you test this regression equation by giving this is the exact, right? This is real data. This is the existing data and the real data. You try to give this input in this equation. You try to give 5 in place of x. If you give 5 in place of x, you may not get this answer. If you try to give 5 in place of x, you may not get this answer. You may get an approximate answer near to this, but not exactly this. Why? Because kind of we are generalizing these values and we are trying to form this. Okay, so when you are forming this equation, you are trying to give this age of the car as input. You test it for your own data, like whatever real data we have. If we try to test it for it, we may not exactly get as 5,70,000. It may be little varying with the actual value. Okay, that's the difference. For that, we have to do optimization. That's what we are learning about vector calculus. We are studying about differentiation, partial differentiation, and gradients. Because we use those concepts in optimization. When you formed a regression equation, this is your W and this is your B. In our ML terms, we say WX plus B. So you found out the value of W and B using values of X and Y. So this becomes your equation becomes something like this, or maybe this minus 502.45 plus 3781. When you get this equation, are this value accurate? Is this model giving perfect accuracy, or I would say, is it giving the best accuracy? Best accuracy when in this case, in this example, if you see in this car and price example, if you see, if you give the input as 8, is it giving 4,10,000 as the price or not? You are giving the car's age as 8. You check yourself and find out whether it is giving the exact actual price as 4,10,000 or not. It will not give. There will be a slight error in the value, or there is some difference in the value which is we have calculated and which is the actual value. So this is the value which we predicted, and we have some actual values. So there is a difference in the values. Okay. What now, when you have difference, this is my model wx plus b. I got this using the historical data. You using the values of y and x, I tried to find out the value of w and b. Now we have different ways. How? See, this is my equation. For example, 10x plus 3.5. When I am doing testing for this using the real time data, using the real data whatever I have, I'm not getting the exact values. There's a slight difference. So what we have to do, we have to optimize this value, this weight and this error variable. Okay, so we have to optimize this w and b values. Maybe when I make this equation to 9.886 plus 3.72, if I can just I change this, just assume that we change the value to like this. Okay, when you change the values to this 9.8866 plus 3.72, right? In this case, maybe we are getting better values. We are getting better values. So it means we have to find out the optimized values of this weight W and this error variable B. Okay. So for that, we use the technique optimization using gradient descent. What is a gradient again? In vector calculus, gradient means collection of partial derivatives. Okay, so for a function, we'll see what is a gradient, what is Jacobian, and how we use that concepts of vector calculus or gradient in optimizing this regression equation so that we get a better equation like this, which gives better accuracy. Maybe when I am testing this data for given x as 3, if I give 3 here, it becomes 33.5. For this is equation 1, this is equation 2. So for equation 1, when I give x as 3, 30 plus 3.5, 33.5 I get here. Same x you give here. If you give x value as 3 for this equation, so this is your y value 33.5. Here what is the y value if you calculate? So 9.886 into 3 plus 3.72. See, you are getting 33.378. Okay, so there is a difference between the this is what you are getting with the standard model. If I apply some, if I do some optimization, I'm getting this value. Maybe actual value y is equal to I would say it is 33.37. Maybe it is 33.57. If this is the actual value, you see, originally you got 33.5. No, 27. Let's check 33.27. So original value is 33.27, but the standard one which we found out our using regression technique, we got 33.5. Here it is little closer. So target is to reduce this error value between the actual and predicted. So what is our target here? We have to reduce this difference. So the predicted value, how we write it? We write it something like this: y cap minus y. This we have to reduce it. This difference we have to reduce. So summation of this yi. Okay. So this yi cap minus yi. If I can no reduce this. Reducing means optimizing. Means I have to find out minimum. Okay, I have to minimize this error value, which is the difference between the actual value and the predicted value. If I can reduce this, we are forming a better regression model. So to reduce this, we apply optimization technique. But before we go to optimization, we have to study about the differentiation and partial differentiation concepts. You are all well versed with those concepts. We'll quickly revise in few minutes about the rules of differentiation, partial differentiation, like chain rule, product rule, sum rule. All those we'll try to see, so that we that is helpful for us in optimizing the weight and bias parameters of regression. Okay.